Alright, you guys, today we're doing 10.2. We're looking at vector operations. So our last two videos were just the introductory lessons, what are vectors, and some basic calculations of magnitude and distance. Today we'll look at some different operations involving multiple vectors at once. Before we do that, though, we're going to look at how to find a vector when you're given two coordinate points. So in the first video for this unit, we talked about vectors in standard position, so maybe a vector that looks something like this. For this vector, it's easy to figure out the components, meaning like the x and the y, because it starts at the origin. Now, if you have a vector that's just kind of hanging out, like between two random points, like here and here, it might be a little bit harder, not harder, but you have to do a little bit more work to figure out the two components because it's not just starting at the origin where you can just count. What you could do, like from a graph, I could literally count, okay, how far horizontally, and then how far vertically, right? Now, most of the time we don't want to take that time to actually graph two coordinate points, so we can just do the calculation by hand. So if you have two coordinate points, so these would just be like regular dots that represent a vector. To figure out the components of the vector, you're going to do the terminal point. So terminal means ending, minus the initial. Right, you're just going backwards, like from where you ended, you're subtracting where you started. So point D here, that's the terminal point. Point C is the initial. We're starting at C, going to point D. So if I want to figure out the components, we're going to call this vector CD, right, going from C to D. Remember, this is our vector symbol. I'm going to draw my vector brackets. I'm going to do the terminal x value, so -2, -7, comma, the terminal y value, so -1, minus the terminal initial value, -3. Oops. So minus a -3. Okay, we're subtracting terminal, so second point minus first point. It's just a way of calculating the distance, right? Instead of drawing it and counting, which you could do, it just takes more time. We're just doing the subtraction ourselves. So I'll simplify this. -2 minus 7, -9, -1 minus -3, that becomes addition, so -1 plus 3, +2. Now, if I were to plot these points, I'm just going to sketch it. 7, -3, that's like somewhere down here. And -2, -1 is somewhere up here. So here's what the original vector looks like. Okay. If I'm going to draw this vector in standard position, that means it starts at the origin and goes horizontally -9, so like somewhere up here, and then up 2. So it's just a sketch here, but you can see like these should have the same magnitude and the same direction. It's basically like if I could pick up this vector and put it on the origin, this would be what it looks like. Okay, so this is our vector component for CD. All right, so let's look at example 2. So now we're doing the same thing. We're going to find the order or the vector that represents this ordered pair, and then we're going to find the magnitude and direction. So we're looking from point A to point B, so we'll call it vector AB. Subtract the terminal minus initial, so -1 minus 2, comma, 3 minus 4. Notice we're subtracting like the corresponding pieces, x minus x, y minus y. Simplify, -1 minus 2 is -3. 3 minus 4 is -1. Okay, so there's my vector. So if I'm going to find the magnitude, that means I'm doing the magnitude of AB. Remember, this is our magnitude symbol. It's the length. So I can do the Pythagorean theorem, square root, and I'll use my vector components. -3 squared plus -1 squared. And we'll simplify this instead of getting a decimal approximation. -3 squared is 9, -1 squared is 1, so 3 plus 1 gives me root 10. So that's the length of that vector. And then I want to find the angle, meaning the direction, theta. So our angle is inverse tangent of -1 over -3, the y-coordinate over the x-coordinate. And this guy we can type in our calculator. We won't use the unit circle much here. We'll pretty much always just type it into our calculator in degree mode, get a decimal, 18.43 degrees. Now let's think about where this vector would be. -1, -3, put us somewhere down here. That's my vector. So this degree measure, let's put it back to our cardinal direction, because 18 degrees would be somewhere in quadrant 1. So for our cardinal direction, this is west, south, so we're 18 degrees south of west. Okay. All right, I want you to try example 3 on your own. It's same idea, find the vector, and then again, this symbol just means magnitude, so you don't need to do the direction for this one, you just need to do the magnitude. So pause the video, take a minute to try this one, and then come back to see the answer. All right, so here's my work for example 3. Here is my vector, 11,5, and my magnitude was root 146. So feel free to pause again to look at that work a little bit more closely. Example 4 starts to introduce some three-dimensional vectors, so we'll look a little bit more closely at those in the next lesson, but every once in a while I'll work with a 3D vector, and the rules work exactly the same way. So if I have 2 coordinates, I'm going to find the vector components from A to B, the same way I did with 2-dimensional vectors. So start with your first point. So this is actually x, y, and then z would be our third one. So subtract the end minus the beginning. So -4 minus 2, 5 minus 1, 7 minus 3. Simplify each of those. -6, 4, 4. Three-dimensional vector. You'll see a picture of that in the next unit, or lesson, sorry. And then again, we're finding the magnitude. Those bars mean magnitude. This should be a little arrow. So the magnitude of vector AB works the same way. So we're going to do the square root of each component squared. So -6 squared plus 4 squared plus 4 squared equals square root of 36 plus 16 plus 16, which equals square root of 68, and we'll leave it like that for our magnitude. Okay. Now, the last piece for today is just operations with vectors. So these are operations between different vectors. The nice thing is these all work pretty much like you would expect. So for vector addition, that means I'm adding 2 different vectors. So vector x plus vector y. So let's define those up at the top here. Let's say vector x, we're going to use letters. So a comma b. And let's say vector y is c comma d. Okay, so remember these would just be placeholders for numbers. If I'm adding those 2 vectors, pretty straightforward. I'm going to add the x components and the y components. So I would do a plus c comma b plus d, basically like you'd expect. Corresponding pieces get added together. If I'm subtracting, again, works like you'd expect. A minus c, b minus d. Lastly, we have scalar multiplication. Scalar is just a regular number. Okay, so if I'm multiplying, let's say, a number k, so again, k is just a placeholder, would be like 5, 12, 32, 1/5, whatever, times vector x. It would look like k times vector a, b. And just like parentheses, we would just distribute. So it becomes k times a and k times b. So let's see what that looks like with a few examples here. So I have some vectors defined up at the top. it says find u for the following algebraically. So finding vector u just means do the operation you see here with vector v or w. Okay, so I'm going to do -3 times vector v. -2 times 5. Pretty straightforward. Exactly like you'd expect, we'll distribute. -3 times -2. -3 times 5, +6, -15. And I'm done. Not too complicated there. The next one, we're adding some vectors. So vector v plus vector w. So vector v, -2, 5, plus 3, 4. Add the corresponding pieces. Pretty straightforward. -2 plus 3, +1, and then +9. I was going to show you graphically, but I don't think we have time, and we don't need to worry about that at this moment. So we'll keep going forward here. Subtracting vector w. So subtracting order matters, just like it does in with regular numbers. 3, 4, minus -2, 5. 3 minus -2. 4 minus 5. Subtracting a negative becomes addition. 4 minus 5. -1. Okay. And let's see, we got 2 more to try. We're going to combine some operations, and then you'll do a little bit on your own. Okay, I'm actually just going to do one of these, and then I'll have you do the last 2 on your own. So, again, I just rewrote v and w for you. So here we're doing w, so we can substitute in 3, 4 for w, minus 2 times vector v. Okay, so we're going to follow our order of operations. So we're going to do our multiplication before we do the subtraction. That means I'm going to distribute the 2. When I do that, I'm just distributing +2, and then I'll just leave subtraction in between so I don't get confused on whether I'm adding or subtracting. So we still have 3, 4, minus, and now 2 times -2, -4, 2 times 5, 10. Now I'll subtract just like we did before. 3 minus -4, so first component minus first component, and 4 minus 10. This becomes addition, so we end up with 7. 4 minus 10 is -6. One thing I want to point out, you're going in like regular order, first minus second. The only time we go backwards is like we did at the beginning. Let's scroll up really fast here. When we started with just regular coordinate points. That's the only time you go backwards, like second thing minus first thing, okay? Sometimes people get confused with that. So I want you to try F on your own, and then also try the last one. It's just 3-dimensional. The operations work exactly the same way. So when you're subtracting, you would do 2 minus 6, -4 minus -8, 5 minus 9. Pretty straightforward. So try those, pause the video, and then play it when you're done and check your answers. All right, you guys can check your work here. So here's my answer to F. My final answer is 1, 32. Again, feel free to pause so you can see each individual step. I did follow order of operations, so I distributed first and then added. And then the last problem, 3-dimensional vector operations work the same way as 2-dimensional. So here's my first one, subtracting each component. And then my second one, again, I distributed first. Be careful with the 2. I distributed +2 so that I didn't have to worry about flipping my subtraction to addition. So I would always just do that so you don't have to worry about changing this sign. And then the subtraction will work out naturally.